Okay, so for the first case where we try to solve this joint second order ODE, okay, so here we assume A is smaller than 0, which means this one is smaller than 0. Okay, and as much as we try to solve a homogeneous ODE, we try to change the second derivative into s squared and then equals A, and then this is our original function. This is second derivative. So we change it to 1. So we have s squared equals A. But here, A is a negative number. This is negative. Okay, so in this case, s should be plus or minus square root of negative aj, something like this. So because A is a negative number, A is a negative number. So negative A is a positive number, then we can take the square root of it. And then, but it is like A is negative 1 multiplied by negative A, negative A. Okay, so we have a square root of negative 1, which is J, and then square root of negative A. Negative A is a positive number, so we can take the square root of it. Or we can actually write A is equal to negative k squared, because k squared is it must be larger or equal to 0, so negative k squared is smaller or equal to 0. Okay, so in this case we can write it as plus or minus negative k, so k squared, so it becomes k squared and then j. Of course, k is a positive number, so we can write it as plus or minus kj or jk or jk. Okay, so this is the this is the solution. S equals plus or minus jk, and this ODE is with respect to x. So ex of x should be exponential to ikx, or you can write it as exponential to jkx, or negative exponential to negative ikx or negative jkx. Okay, so these are the two solutions correspond to these two s values. And similarly, for et of t, we solve this one, which means that we have s squared equals a c squared, and then we change this to 1. And then similarly, a is a negative number, so we have negative k squared c squared. Okay, in that case, we have s equals plus or minus kc and then times j, kc times j. Okay, but here, rather than writing it as an exponential to I kcj, we write it as maybe I just write it as I, just make them look alike. Okay, rather than writing it as exponential to I exponential to I kct and exponential to negative I kct, we write it as exponential to I omega t, which means that omega is kc. Omega is kc. We get this expression. Okay, and actually, as much as this is the homogeneous solution, this is the homogeneous solution. Okay, which makes it like it should be like x should be something like a exponential to I kx plus b exponential to negative I kx. So that as much as this is the solution, this is another solution. So the linear combination is also the solution. And similarly, this one. But yeah, maybe we don't use C and E Maybe we can use exponential to t. Maybe we can use a d exponential to I omega t, then plus not e, and f exponential to negative I omega t. Okay, and if you still remember, the overall solution we should have is e of xt should be ex of x times et of t. So we need to multiply them together to get the e of xt. Okay, so e of xt is this one multiplied by this one. Okay, why it look like this? Maybe we can open a page, new page to write it out. And this omega equals kc is coming from here. Omega equals kc. This is what we get. Okay, so let's see why we can get this expression. So maybe I can open a page. So just now I wrote ex of x is a exponential to ikx plus b exponential to negative ikx, and then et of t is c, not c is speed of light, d exponential to I omega t plus f exponential to negative I omega t. Okay, so ext should be ex of x times et of t. Okay, so it looks like a exponential to ikx plus b exponential to negative ikx times d exponential to I omega t plus f exponential to negative I omega t. Okay, so we can distribute this one to here, distribute one to here. So we get ad exponential to I kx plus omega t, and then we get af exponential to I kx minus omega t. Okay, and then plus this one distribute. So we get bd exponential to negative I kx minus omega t, and then plus bf exponential to negative I kx plus omega t. Okay, so we get 4 terms, and actually we may write it as a big ABCD like this one. ABCD like this one. But we try to reorder it. So we put this term here. Okay, this is a exponential to I kx plus omega t, and then we put this one in the second place. So this is b exponential to negative I kx plus omega t. So we try to keep here is kx plus omega t. This is also kx plus omega t, although this is plus, this is minus. And these 2 terms referring it to when the EM wave is propagating through the negative x-axis, and then we have another 2 terms. This one is plus c exponential to I kx minus omega t, and then plus this one is d exponential to negative I kx minus omega t. Okay, and these two are propagating across the plus x-axis. This is negative. Okay, so in some sense we only need to consider one of them, maybe positive x-axis, and then we can just ignore it. Or sometimes there exists both of them, then we can just consider them one by one. a part of it is propagating across the negative x-axis, and then part of it is propagating across the plus x-axis. So we can just separate them. And the point here is, actually, when we try to solve the wave equation, this wave equation is a real value equation. So we also suppose the solution to this wave equation is also a real function. But here we have a complex function. This is a complex function. This is a complex function. If you still remember, exponential to j theta is cosine of theta plus j sine of theta. J is I is negative square root of 1. Square root of negative 1. Okay, so here we hope this whole thing to be a real function. So it should satisfy a condition is like A equals B conjugate. This is the complex conjugate. Okay, and similarly, C equals conjugate of complex conjugate of D. And this will make things like this is like a C exponential to I kx minus omega t, and then plus C conjugate exponential to negative I kx minus omega t. Something like this. So this thing is similar to E exponential to I kx minus omega t, and then the whole thing complex conjugate. So we have this thing complex conjugate added with this, adding with itself, which is like if we have A plus JB, and then if we add it with the complex conjugate of itself, it will look like A plus JB plus A minus JB, and then the imaginary root cancel each other. It becomes a real value. So if we just take the complex conjugate, exponential j theta, if we take the complex conjugate, this is cosine theta minus j sine theta, which is nothing but exponential to negative j theta. So we need this condition to make this thing to be real function. And actually the real function is like the real part of this thing. The real part of this thing is nothing but exponential, no exponential anymore, cosine of kx minus omega t. This is what we get. And then maybe we can have a xe xt is nothing but em, something like this. So we get the expression. Actually, in the textbook, it used sine rather than cosine, but there's just a phase shift between the cosine and sine. So yeah, we don't need to care about whether it is cosine or sine. So they should have the same. They should have a same shape, but with a phase shift only. So maybe we can also put this one as plus phi. But even on the textbook, it doesn't include the phase, so just forget it. So we can actually get this expression by having A equals the complex conjugate of B, and then C equals the complex conjugate of D. We can get this expression. And similarly, we can solve for this one, or we can directly go from Laplacian of B equals 1 over C squared, second partial derivative of B partial T, like this. And then we try to solve this one again, we can get this one. Or we can make use of this one is Faraday's law, and then we write it in one dimension. So this one is nothing but a partial e partial x equals negative partial b partial t. Okay, and then we try to plug in e here. E is this one. We try to plug in this one into here. So we get partial b partial t is negative partial e partial x, and then we take this partial derivative with respect to x. So em is here, and then cosine become negative sine, and then the negative sign cancel with this one, so we have a plus sign here, and then cosine becomes sine kx minus omega t, and then the chain rule, we need to take the partial derivative, we take the derivative, partial derivative with respect to x here, so we get a k here, which means that partial b partial t is this one, and then we try to integrate both sides, so we get b of xt, and then sine become negative cosine, and then this we need to chain rule with respect to t, so we need to divide negative omega. So this negative cancel with that negative, so we still get a plus sign here, and then we have k over omega because the chain rule here. So we get k over omega em cosine kx omega t. And then actually in the textbook we have a bxt equals bm cosine kx omega t, which means that em over bm, or you can say k over omega em should be bm. Okay, which means that em over bm is omega over t, omega over k. And some page before, what we get is this one, omega equals kc. What we get is omega equals kc, which means that omega over k is c. So we get this is the ratio between the E field and the B field in the EM wave is the speed of light. So we get this one. So k over omega e times em equals bm. So we get em over bm is omega over k equals c. Okay, so we get 33.1234. 3 is actually the speed of light. 3 is here. C is a 1 over square of mu naught epsilon naught. Okay, so yeah, so this is actually the solution to the wave equation in one-dimensional. And if it is in three-dimensional, which means that this is the solution to second partial derivative of E, and then x equals 1 over c squared partial, like this. And this is the solution to gradient of E, Laplacian of E equals 1 over c squared, and then second derivative of E, and then partial derivative of T. Okay, like this. So this is a solution. Okay, so you can see, rather than writing x and t here, we write r is the three vector. And yeah, so here, rather than writing it as a k times x, k can be a vector, the wave number. Okay, if you still remember, k is the wave number. It can also be a vector, and then this wave number is dotted with the r, and then minus omega t, because inside should be a scalar without dimension. It's dimensionless scalar. And then cosine of this term. Okay, so before this is achieved, but I convey it as a PDF, so we cannot move. But actually, it is like suppose this is the EM wave direction from top left to the bottom right, and then so you can see that this is the E field, this is the E field, this is the B field, and then it follows the right hand rule. E cross B is this direction. Is this direction. This is the direction of the pointing vector. The direction of the pointing vector. So it feels like the EM wave, the E field is oscillating up and down, But with respect to the time, it feels like the E field and B field are propagating. But actually, the E field and B field can't really move. Okay, so before ending this slide, we still have a page about the energy density of the EM wave to tell you why the Poynting vector will look like that. Okay, so in the equation, we have EM, BM to be the magnitude of the E field and B field. So we also define the root mean square value. ERMS is the amplitude divided by square root of 2. BRMS is BM divided by square root of 2. Okay, and if you still remember, we learned UE is the energy density. Energy density. Energy density stored in the E field, and then this is the energy density stored in the B field. So if you still remember, UE is half of epsilon naught E squared, and they are derivative. So we change E to B, and then change epsilon naught to 1 over mu naught. So it becomes B squared over 2 mu naught. Okay, so these are the energy stored, energy density in the E field, energy density in the B field. Okay, so in this sense, as we have E equals CB, or E over B equals C, which means that E equals CB. So we just substitute E to be CB. Okay, so we try to explain this square. So we have C squared, B squared, and then C. We have C equals 1 over square root of mu naught epsilon naught, which means that C squared is 1 over mu naught epsilon naught. So this green term becomes this mu naught epsilon naught in the denominator. And in that sense, epsilon naught and epsilon can cancel. So it becomes B squared over 2 mu naught, which is the UB. Which means that in the EM wave, the energy stored in the E field, the energy density stored in the E field is the same as the energy density stored in the B field. And the total energy will be the sum of it. So it is energy per volume. U, the total energy stored in the EM wave. So it is energy over volume. Okay, should be UE plus UB. So they add together and then become 2 times of it, because this one and this one are actually the same. So it feels like 2 times of this one. So we have epsilon naught times E squared. Okay, so the Poynting vector is the energy per time per area. So it feels like we need to. So this is the cross section area, but this is the volume. So we need to multiply something and divide something to make it like a volume. So the area should multiply by the length. Okay, actually we multiply it in the denominator, so we need to have length multiply in the numerator, and then over the time. So this one and this one are the same, and this one become the volume. Okay, so here we have energy per volume. So these two become this one, and then we have length per time. Length per time is actually the speed of the wave, so which is the speed of light. It becomes the speed of light. So altogether we have a C epsilon naught E squared, and then we have a E equals CB. So we have C times epsilon naught, and then times E, and then times CB, because E equals CB. Okay, so it becomes this one is E and B, so we write it here, EB, and then we have C square epsilon naught. C square is 1 over mu naught epsilon naught. So we have mu naught epsilon naught. This is actually C square, but mu naught epsilon naught is in the denominator, and then we have an additional epsilon naught here, which is this one, which is this one. This one go to here, and then C square go to here. So epsilon naught and epsilon can cancel. So it finally becomes E times B over mu naught. And that's why S is defined as E cross B over mu naught in the textbook. Okay, so I think